Welcome. Hi, I'm Yogesh Syadri. Today I'm here to discuss how we can navigate the unpredictable world of diesel prices with the prediction model. So, as we know, the importance of diesel prices and the importance of the economy needs for the forecasting model for this prospect, what I thought is of. So, diesel prices are significantly influencing sectors like transportations and logistic business nowadays. So, fluctuations in different in diesel prices can dramatically affect operational costs and the product pricing of the daily movers. As diesel prices really matter for businesses that depends on shipping, on transportations. So by using this predictive model, these businesses can plan better and make smarter choices after knowing the exact what accuracy gonna be happen for the upcoming future. So this not only helps us and them for the businesses to save money, but also make their operations run smoothly on the road. Businesses that depends on diesel, like trucking and shipping companies, have tough time when diesel prices keep changing. So these ups and downs can mess up their budget, make costs go up, and even put them at the disadvantage compared to their competitors. So the uncertainties around diesel prices make it really hard for these businesses to plan ahead what's going to be affecting, and everything from buying fuel to setting prices and ultimately their financial stability they can move upon for a smooth process. By using a dataset from the Federal Reserve economic data, so which include the price of diesel sold in the US each week. So this date starts from the mid 1990s and goes up to 2024 in between the month of March. So the key pieces of information we look at are the date of each record uh, and the diesel price at the time, so which helps us to analyze trends and patterns over the years and floating up the value. So as the methodology involves time series analysis using the AREMA model, which stands for autoregressive integrated moving average. Here is what's this approach entirely giving us data cleaning and preparation. So the data is first clean and remove any inaccuracies or the irrelevant data in the details. So this step ensure that the analysis is based on the most relevant or the precise data possible as we taken. So the model development in the AREMA so is applied to the prepared data, the model, and that to adapt at analyzing and forecasting trend based on the historical price that we taken off. So and next moving to the testing and refining. Finally, the model accuracy is evaluated in the basis. So the technique and adjustments are made necessary to refine its prediction. So the reliability to enhance in a smooth way, and the accuracy has to be more in a prayer way. In our analysis, we looked closely at trends and patterns in US diesel sales prices over the years. So we have noticed some interesting fluctuations which we have captured in the visualization from time series plots. So these graphs make it easier to see how diesel prices have changed from help us to understand the bigger picture of what happening with the diesel cost as compared to previously and now. So all this all about. The chart give us a visualization snapshot of diesel prices over time. So it's break down the data into clear patterns and change by the years, showing us when prices tended to go up and down, or it's look at the rhythm of diesel prices from the mid 1990s all over the way through the 2025 as the forecasting help us to the spot where we can predict that. So the regular ups and downs and any big shifts in the prices that could really impact our planning and budgets too. As we can see some statistical checks to see if your data on diesel prices is consistent over time, or if it's really has too many ups and downs. Here what we find on ADF and KPSS test. So in ADF test it's a really check for data, the results minus 2.94 something, so with a p-value of 0.17 tell us that data probably has too many swings to predict the future prices, as it which means we need to adjust our approach. So coming to the KPSS stats, this one's look like a second opinion. It's gave us a different signal as statistical of 13.17 with a p-value of 0.0 on 00, suggesting that if we account for regular trends, the data might actually predictable. So The mixed signals from this like test means we need to take a closer look, like probably tweak our data a bit more to make sure like our forecast are on a one point way. So as we got these two kinds of graphs here as to like help us to predict diesel prices by looking at the patterns of in the data. So ACF like autocorrelation function for differentiated series, like imagine if today's impact makes tomorrow's like effect. So that's what the first like the first big spike in the ACF graph is looks like. So it means our recent diesel price gave us strong clues about like what's going on to be next. So but the influence doesn't last long. So just like how today's weather like matters like less for the predicting the weather of the next week, so the graph shows this effect fades quickly all the time. So most of the time the predictions stay within a common range, telling us that aren't any strong long lasting patterns in the changes of diesel prices. And coming to the next plot, PAC of partial autocorrelation function for differential series, like this graph digs into the relationship between past and the future prices a bit more selectively. So after the first big drop, the impact of past prices on future one is pretty small. So that's not much going on after the immediate past, so meaning that beyond a short period knowing past diesel prices like doesn't help us much predicting the future ones. So because of this quick drop off in the graph, we are looking at the using a model called AR1. So think of it as like a tool that uses like most recent prices changes to the predicted be next one, so which seems to be perfect for how diesel prices behave uponly. So here these charts is like a game of expectation versus reality for diesel prices. The blue line shows what actually happened with the prices, while the orange lines is what a model thought would happen. Like as you can see, they're pretty close to each other most of the time, which means a predictive like or the predictions are usually on the right track. So there are few spots where they don't match perfectly. So and those are the areas we'll try to get better at predicting. So as this slide shows the step we took to make up predictions and how we did it used a forecasting model called RMA, so which is just a fancy way of saying it's like good at predicting things based on the past patterns. So here is what we found out. So pulling out the model, so we created RMA model using our historical diesel prices as previously mentioned. So teaching it to look like a pattern that can tell us about the future prices. So model details, the model like uses the three past values like RMA 310 means. So today guess the next one, the numbers are like 0.8 and minus 0.10 and 0.11 tell us like how much each past values affect the prediction. So coming to the model performance, we can have some like statistical sigma square like or the AIC, which help us to understand how well a model fits the data. So the lower less like these numbers are the better the model is going to be. So coming to the error measures, this is how we can check the model accuracy. The closer these numbers are to zero, the better the model predictions are. So the forecast graph finally it's like shows us the actual prices in the black, like the price of model predicting the like in the bit the blue. So the shaded area shown as where like we think price might go into the future, like in the future giving us a range to work within. So like taking a look at this chart, and where the black line is a journey with diesel prices showing the real changes from 2000 up to until now. So now see the blue shaded area, like that's a map into the future stretching out to 2025 up to. So it's a model prediction of where the diesel prices could go. It's like a bit like a weather forecasting as mentioned, like we are pretty confident about the near future. But as we look further out towards 2025, we have given ourselves a range to account for more possibilities. This breakdown diesel prices like into three main parts, which help us to understand like whole picture, like trend component, Like first going overall the direction that diesel prices are moving in the long run. Think of it like hiking up a mountain. So the trend is like a general path upwards to be. So coming to the next seasonal component, these are like patterns that repeat themselves at a certain time during the year. So like how some trends are busier during holiday seasons and some stuff. So residual component, these are like unexpected potholes or detours that the trend or and the seasonal parts don't cover. So they're the random bits that we can like can't easily predict. By looking at each of these parts separately, we can get into a clearer idea of what drives changes in the diesel prices and how we might predict them. In coming to the RMSE stands for like root mean square error, and MAE stands for like mean absolute error. These are the ways to measure how far our predictions are from the actual diesel prices. The value given like RMSE 0.043 and MAE is of like 0.023 are like pretty low, which means our predictions are usually quite close to the real prices. This is great news of like for predicting diesel costs accurately. So our predictions for diesel prices are a handy tool for everyone. So from everyday folks filling up their cars to companies managing fleets of trucks to the officials setting energy policies. So and to investors looking at energy market. With this information, they can all make smarter plans for the future, like budgeting better, deciding when to buy fuel, or investing wisely. So this our models looking ahead and showing us that diesel prices are likely to climb. So it's a head up for everyone involved to rethink their budgets, find smarter way to save on costs, so and get ready for the pricier fuel future. So let's steer into this with clear eyes and smarty planning. So as feeling the future, navigate rising cost with informed decisions. Last but not least, a big shout to the amazing folks who guided and supported me during this entire journey and study towards this. So, your wisdom and help have been invaluable for me. So, thank you so much.